This is a review for exponents and logs. Let's start out with the even numbers, number 2. Okay? So, first you got to check to see if they have the same base number. These two do not have the same base number. So, first thing you need to do is you need to change this 32 to where it has a base of 2. So you ask yourself, 2 to the what power will give me 32? Well, if you don't know, you take your calculator and you go 2 to the 1 power, that gives me 2. 2 to the 2 power, gives me 4. 2 to the 3 power, that gives me 8. Keep doing that until you get to 32. Well, you find out that 2 to the 5th power is going to give you 32. So, 2 to the negative 2b is equal to 2 to the 5th power. Now, our bases here are the same. Since our bases are the same, we can set our exponents equal. So, negative 2b is equal to 5. Divide both sides by negative 2 to get the b by itself. You get b is equal to negative 5 over 2. And that is your answer for b. Continuing to number 4. For number 4, again you look. Are my base numbers the same? No, they are not. So, you need to change them to have the same base. Well, this one's a really simple one. I know that 4 squared will give me 16. So I'm going to change the 16 to 4 squared. So 4 squared, 2b minus 2 is equal to 4 to the negative 2b power. Now you could have also done 2 to the 4th power here and 2 to the 2nd power here, and it would have given you the same answer in the end. But let's work it out this way. All right, we have the base number 4 for each of them now. Their exponents are now equal. So 2 parentheses 2b minus 2 is equal to negative 2b. Now, since these are equal, we need to go ahead and distribute here so that we can simplify the equation. So 4b minus 4 is equal to negative 2b. Go ahead and move this 4b to the other side so that you can isolate your b's. So you get negative 4 is equal to negative 6b. Then to get the b by itself, you're going to go ahead and divide both sides by negative 6. And negative 4 divided by negative 6 is, of course, is going to give you 4 over 6. But go ahead and reduce that to 2/3 is equal to b. Going now to number 6. All right, number 6. You're going to have to change it to where they have all the same base number. Okay, so 125. 5 to the what is 125? 5 to the 3rd. Okay, 5 to the what is going to give you 25? 5 to the 2nd. Equals 5 to the 3rd to give you 125 times negative 3x here. Okay. Now, base numbers are all the same, so therefore we can do an equation with the exponents. Remember, if you're multiplying the base number, the exponents are going to be added together. So this is 3 parentheses 2x minus 2 plus 2 negative 2x equals 3 negative 3x. All right, we have a lot of things here we're going to have to distribute to simplify this problem. So you're going to get 6x. Move this down a little bit. I don't know what that weird square is. That's 6x minus 6 plus negative 4x is equal to negative 9x. Combine like terms here. That'll give you negative 6 plus 2x is equal to negative 9x. All right. Subtract 2x from both sides. Negative 6 is equal to negative 11x. Divide both sides by negative 11. And you're going to get x is equal to 6 over 11. All right, on to number 8. All right, number 8 here. We're going to go ahead and multiply the base numbers, or go ahead the coefficients of each one here. So 3 times 3 will give me 9. We only have one variable, m. And what we do with these variables, since they're multiplied to each other, you're going to add the exponents. So 2 plus 2 plus 2 is 6. 9m to the 6th power is your answer. This one, we have a whole lot of stuff here. Kind of a mess. Yes, we know that x to the 0 power is going to give you 1. But we do have these y's, sorry. But one of the things that are unique here is the whole thing is raised to the 0 power. Anything raised to the 0 power is 1. It doesn't matter what's going on inside this parentheses. It could be anything. But there is a 0 power on the outside. Therefore, this is 1. This whole thing is 1. Number 12. Here, you have to ask yourself, 2 to the what power will give me 16? Okay? Because basically, you're basically asking 2, what power is equal to 16? Well, that power is 4. So your answer is 4. Number 18. There's a lot of work to be done here, so be very careful and listen to what I'm saying. Okay, first things first. In number 10, we found out that anything raised to the 0 power is 1. Immediately, I see that this x to the 0 power here, that is 1. So therefore, 1 times anything is not anything. So we're not even going to worry about that x. It's irrelevant. It's not important. It's only 1. I'm going to go ahead and not worry about the x, so I'm going to cover it up there. So I'm going to worry about only this at the top here. So let's simplify the top. Well, if I'm multiplying the base numbers, which are y, we're going to add the exponents. So that's y negative 2 plus 3/4 at the top. At the bottom, I'm going to go ahead and distribute this 5/4 to the x and to the y. So that's x to the 5/4 power, y to the 2 times 5 is 10, so 10/4 power. Okay? So I'm at this point. Let's go ahead and add these exponents together. Okay? If you're having trouble adding fractions, I suggest you work with it, or go ahead and just put it into your calculator. So I will find that negative 2 plus 3/4 is going to give me negative 5/4. So y is negative 5/4. Yes, it's negative, and yes, it's in the numerator. Do not worry about that right now. Let's go ahead and worry about everything else. Okay? At the bottom, again, we're just going to leave it like it is. We're going to leave it 5, x to the 5/4, and y 10 to the 4th here. I'm not going to change this 4. Why? I'm not going to reduce this, and the reason I'm not going to reduce it is everything over here is divisible by 4. It would just make things too complicated if we tried to make it divisible by 4. Okay, the next thing I'm going to do, we do have this negative in the numerator. We need to bring it to the denominator. Okay, so at this step, I'm going to go ahead and, what do I do to make it positive? Well, I bring it to the denominator. So it's going to be 1 at the top. That's the 1 is like a placeholder. So it's x to the 5/4, y to the 10/4, and then it'll be y to the positive 5/4, because I brought it to the denominator. All right, now we're at this step. To complete this step, we're going to add the y's here. So, because their bases are being multiplied, that's x to the 5/4 power, and that'll be y 10/4 plus 5/4. And of course, 10 plus 5 is going to give you 15, so it's 1 over x to the 5/4, y to the 15/4. There is some other steps you could do here, but I want you to go ahead and leave it in exponential form, not to change it to radical form, and this would be the answer that you would see on a test. So this is the answer I'm looking for. All right, let's continue. Let's look at number 20. Number 20, the directions will tell you, I want you to rewrite this in exponential form. Well, exponential form is the base is 27, the exponent is 1/3, and the result is 3. That is all you need to do for this question. Number 22 is written in exponential form, and they wanted to write it in logarithmic form. Logarithmic form is when you write log. A little subscript of 12 is your base number here. The resultant is 144. We're going to write that big. And it's equal to 2, which is your exponent. The point of doing logs is to find out what an exponent is. Therefore, the result here is the exponent. Let's go down to number 24. For questions like number 24, they're going to ask you to condense. Okay? What we have here is a logarithmic equation where everything is written out. So we need to condense it to something simpler. Well, one of the first things I want to look at is exponents. If it has an exponent, it's going to be written in front of the log. Okay? Right here there's nothing, so there's just a 1. This will be an exponent of 5, and this is an exponent of 6. So log 811 plus log base 8, 6 to the 5th power, minus log base 8, 7 to the 6th power. You see how this 5 went to the 6th power here? This 5 went to the base number 6, and this 6 went to the base number 7 here as its exponent. Okay? Now, addition means multiplication with exponents, and subtraction means division. So, log base 8 is going to be 11 times 6 to the 5th divided by 7 to the 6th. And that would be our end result. You don't need to multiply it out on the right. For your tests, they will all be written in as x's and y's as variables. So you will not have to worry about multiplying anything out because you can't. This is all you need to do for this equation. For number 26, they're going to ask you to expand it. And again, it's going to be backwards working from what you did for number 24. So let's work backwards. So if you see multiplication, it actually means addition. Now notice there is no number right here. When it has a log written like this without a base number, you're assuming the base number is 10. So log base 10x plus log base 10y. And that's it. That is our final result. There's nothing else to be done here. Moving now on to number 28. Okay, number 28, the first thing you see is this exponent here. It's kind of out on the outside. Yes, technically you can put it in front, and you can go ahead and follow that step by putting it in front of the log and working it from there. But most students today, when they were asking me questions about this, they were like, well, can I go ahead and distribute it? And yes, the answer is correct. You can distribute it. So that's what I'm going to do now. That'll make it u to the 4 over v to the 12, because 4 times 1 is 4, and 4 times 3 is going to give me 12. That's why I got the v there. Okay, continuing with this problem. Since this is division, it's a fraction, that means they're going to be subtracting. So it's log base 6 u to the 4 minus log base 6 u to the 12. Now, let's remove this exponent. 4 log 6u minus 12 log 6v. Oh, I'm sorry. This should have been a v here. That is my fault. That's a v. My fault. Sorry I did that to you. Any questions? All right, moving on. Number 30. Okay, 4 to the what power gives me 85? I have no idea. I can't figure that out on my own. I'm going to have to use a natural log for this. So r is your exponent. Using natural log of 4 is equal to natural log of 85. I need to get the r by itself, so I'm going to divide both sides by natural log of 4. So r, natural log 85 divided by natural log 4. Again, I'm going to use my calculator to solve this. If you're having problems with using the calculator, you really need to learn to use it correctly. So here I'm going to use my calculator. I'm turning it on. Make sure you clear your screen out. Okay? So what I'm going to do is I'm going to type in natural log 85. Hit enter. Divide that number. See how it does answer from the previous row divided by natural log 4. Hit enter. That's the number I was looking for. Oh, I'm sorry, I put in 84. Log natural log 85, sorry, divided by natural log 4. My fault. The answer is 3.205. Oh, I see this little delay here. 3.205. Got to round to the third exponent. Continuing. Number 32. All right, if you notice here, you need to have base numbers by themselves on either side. You can't have multiple base numbers. So we need to get rid of this 5 first. So subtract 5 from both sides. So 13v plus 3 is equal to 10. Now that I have the base numbers by themselves on either side, I can go ahead and do my natural log. So because this is all grouped together, I'm going to group it together here as v plus 3 ln 13 is equal to ln 10. Let's go ahead and get rid of this ln from this side. So it leaves me with v plus 3 is equal to ln 10 over ln 13. Then subtract 3 from both sides. So my final answer here is ln 10 divided by ln 13 is equal to, minus 3. Now I need to put this in my calculator. Do it exactly as I've written it. So right here I did ln 10 divided by ln 13. ln 10 divided by, don't do the division yet, hit enter. Then divide that by ln 13. Hit enter. Now subtract your 3. And it gives us negative 2.102. So v is equal to negative 2.102. Okay, continuing with number 34. 34 gets a little bit more complicated, not much. Please don't freak out because you see all the equations there. First, go ahead by moving this out the way because we need to get to the e when it's exponented by itself. So it's kind of like treating it like a two-step equation that you did when linear equations. So go ahead and add 3 to both sides. That's negative 10e to the 9x plus 1 is equal to negative 12. Okay, my next step is to get rid of the 10. So divide both sides by negative 10. So e 9x plus 1 is equal to, I'm just going to put 12 over 10. Yes, you can simplify it to 6 over 5. It's the same thing. It doesn't matter. You're going to be putting it in the calculator anyway, so don't do any more work than you have to, other than, the negatives cancel, so just get rid of the negatives. All right, at this point, you have to take the natural log of both sides, so that'll be a plus 1 grouped together. Natural log of e is equal to natural log 12 over 10. Okay, because we have natural log e here, that is equal to 1. I'm going to cross it out because it's just 1. And 1 times anything is just that. So this is 1, that's that, so it's just 9x plus 1. Go ahead and subtract the 1 from both sides. So you get 9x is equal to ln 12 over 10 minus the 1. By the way, this ln 12 over 10 is by itself. That's one term by itself. Okay? This is not part of the 1, so it's the minus 1 comes after this function is complete. Then divided by 9. So we're going to put all this in our calculator step by step. Looking back at the calculator. ln 12 divided by 10. That is our first term. Hit enter. From that, subtract 1. Hit enter. That is the answer of your numerator. Divide that by 9. Okay, so our answer is negative 0.091. Good luck on your test tomorrow.